Hello, everybody. I am Elisabeth El Chami, and I worked with Helena Ochoa and Adam Bercaw to study the house price prediction dataset. The variables that we studied in this dataset are transaction rate, house age, distance to the MRT station, number of convenience store, latitude, and longitude. These are going to impact the prediction for the house price. And the reason why we decided to choose this data set is because we want to investigate the relationship between the variables that we talked about earlier and how they impact the prediction of house prices. And we also want to generate a better understanding of how the real estate business model is changing over time and what other factors are impacting it. To understand if this data set can fit in the linear regression model, we started by evaluating the observations for linear regression. And the first one is homoscedasticity. If we look at the plot on top left, the residuals versus fitted, it shows a very good line. It is fairly straight, close to zero, and the points are kind of scattered and not very clustered, which is a good sign. The normal QQ line shows that all of the points are aligned on the line, except for the ones on the extremity, and the scale location line also shows that the points are scattered and close to the line, which assumes that the homoscedasticity is applicable. And normality, we're going to look at the density plots for each variable. Transaction rate, house age, convenience store, and latitude have a very good density plot, and they show the greatest surface area compared to the nearest MRT station and the longitude. Those ones show a skewness to the left and to the right, respectively. But these density plots don't necessarily mean that we have to rule out these variables, but more additional studies are required to investigate the relationship between these and our dependent variable.
So the histograms for each variable were studied. We actually found that the transaction rate was bigger between 2013 and between the months of April and May. Also, the house age. A lot of people like to buy houses that are between 10 and 20 years old, and they also like to live really close to the MRT station. A lot of people doesn't have access to convenience stores, but they also share something in common, and that the longitude and the latitude between the homes is actually almost they have almost the same. So there's a lot of population that lives within the same location. And we also studied the box plots, and we actually found out that one of the best box plots, meaning that the mean was right in the middle, was the transaction rate and the number of convenience stores, even though the house age was on the lower end of the mean, and as well as the distance to the MRT. Funny enough, for a model, we used the distance to the MRT, but it had a lot of outliers. And even though it had a lot of outliers, that's the one that yielded the best model. We also find out that the longitude and the latitude had a lot of outliers, and it's not exactly like explained. The outliers are like all scattered around between the lower end and the uh, the, the upper end. We did a scatter plot for each single variable to try to explain which model will be able to visualize better. We have found that the price and the house price versus the transaction rate, the nearest MRT station, the house age, and the number of convenience stores yield a fairly straight line. However, the latitude and the longitude were not completely like straight, and the line you can see that is just the slope is kind of weird. We run a single linear regression model for the house price with each single variable, and we choose that the best variable is the distance of the MRT station. We found that the p-value of the model was 2.2 e to the negative 16, which suggests that this p-value is statistical significant. And also the multiple R square out of the all models suggested that this one was the best because it can explain the 45.38% of the data. However, even though the multiple R squares are not really high, we can have a relationship, a weak relationship between the distance with the MRT and the house price. The slope for that prediction was a negative slope, and the intersection was a positive intersection. Furthermore, the linearity of multiple variables versus a house price. So we compare and we cluster together some of the variables and we compare it to the house price, making a multiple regression model of each one as well. We found that the multiple regression model with their transaction rate, house age, MRT station, and convenience stores yield the highest R square value, which means that those are all the factors that people consider into buying a home. Therefore, the price of the houses went up when a house has all these variables into account. We found that, as I said before, the best model was the one that had all the variables but longitude and latitude. We found out that it was statistically significant because the p-value was really low, and it explained the 55.53% of the data. The formula can be found below, and it makes a prediction about the house price that the people will pay if we can insert values there as well. Next slide. We also, for the heck of it, we wanted to compare what if we added latitude and longitude, because we thought that maybe the location of the house didn't matter, but we actually found out that it actually increased the linear regression model, and we found out that the R-square value increased from 0.553 to 0.5224. The p-value is significant, so there is a difference, and location does matter for this model.
So to evaluate the testing data set and evaluate the regression model that we're trying to build here, both single and multiple regression model, we decided to run a diagnostic test and see how the distance to the nearest MRT station can predict the price of the houses. Our diagnostic test is comprised of splitting the data set into testing data set and training data set in a 1:4 ratio. And we used the distance to the nearest MRT station variable from the testing data set, and we plugged it into the equation that we obtained from the training data set. And then the output is going to be the predicted value for the house prices. And we use this predicted value to find the difference between this value and the actual value of the house prices in the testing data set to find a percentage that this percentage is going to represent how much the output from the model is deviating from the accuracy. And it turns out that this deviation is 19%. This deviation is pretty significant for our perception. We think that 19% is very high, and we do not accept that. However, the fact that this deviation is very consistent throughout all of the points is a good indicator. And it means that it is possible to predict that there is going to be 19% deviation from the accuracy, and it is possible to work around that matter. And finally, to conclude our work, the best single linear regression model is established by studying the relationship between the nearest MRT station and the house prices. This is going to be our single variable of choice. And from a multiple linear regression model perspective, we choose the transaction rate, house age, number of convenience store, and the distance to the MRT station. We decided to rule out the longitude and the latitude because they are not relevant to our model. Even though when we looked at the statistical numbers, the R squared value was not very significant because it is lower than 0.95. This does not necessarily mean that we can not make use of this data set, but maybe we can use a different model to assess this relationship. When we looked at the scatter plots for certain variables, some of them were not a straight line. And this suggests that probably a nonlinear multiple regression model can be another suitable representative for our data set study. Thank you so much for watching.